Let's look at how we can use functions with our turtle graphics routines. All of the turtle graphics motions, they are functions themselves that move the turtle around, and we just call them. But we want to write our own functions that can be used with the turtle graphics. We've been doing the hexagon, so let's go back and take a look at it again. It's a very familiar one. What if we were to make a function that could produce a hexagon? Well, it would look something like this. So let's put it here. And let's look at each of the lines. So we're going to define this function, and it's going to be called hexagon. And the first argument, formal argument, is going to be the distance, and that's going to be the the distance between the vertices. Then we're going to input the color, so we can use whatever color we want, and we pass that into the function. So we have color and we have distance as our formal or dummy arguments. Then we put our for loop inside this function, and we just have, for side in range 6, which just means we're going to count 0, 1, 2, 3, 4, 5 as we go through the for loop. So we'll set the pen color to whatever the color is that's input, and we'll move forward whatever distance we put here. We'll turn right 60, and then I'm going to draw a circle this time, or a solid circle at each vertex. So we'll have a hexagon that will have circles at each one of the angles. So that then could be a function that we can use to draw a hexagon. Then let's call the function with some different values, and let's look at what we get. The first call is going to look something like this. We need to initialize everything that we want to with the turtle to get it all set up. So I'm going to set the pen size to 2, which gives us a thick line. And I don't want to draw as I leave the origin, so I've got the pen up command here. And I'm going to go to this location. I'm going to go to x100, y0, and then I'm going to draw a hexagon. So I'm going to put the pen down before I call the hexagon function, and then I'll call it here. So this is going to send in 100 pixels for the distance within our function, and this is going to send in the color. And to do the color, you need to do it like this, double quotes on each side, and then just use the name of a common color here, and that works just fine. So I should be drawing a hexagon at the location x100 and y0. Then I'm going to bring the pen back up, and we'll return the turtle back to the origin. So with only this much, let's run the program, and let's look at the output. Now let's look at the canvas. So here is the call to the function hexagon. We wanted it to be red, and we wanted it to have the circles at each of the vertices, and we do. That's what we have. So now our function can be called on to generate a hexagon. Now, let's do another hexagon. We'll leave that one. We'll always draw the red one. So let's call the function again, and let's have it draw a blue hexagon. So let's copy the call and some associated code here and paste it in. Remember, well, after we draw the hexagon red, down here I had the pen up and I went back to 0. Okay, so we should always lift up the pen when we're finished drawing. So that's the first thing I'm going to do here. So the pen is up, make sure that it's up. And then I'm going to go to a location which is -100. So we had the first hexagon that was red was +100 on the x coordinate, and now we have a -100. I'll put the pen down, and we will call the hexagon function, and we'll use the same length for each one of the sides, but this time we'll make it blue. Then we'll do the pen up, and we'll go back to the origin for the turtle. Now let's look at the design that we get this time. So when I run the program, we can see the design, and it pops up, and here it is. So now we have the two hexagons. We have the red one, we have the blue one. So now we can draw a hexagon anywhere on the canvas that we want to. Now for this next one, let's let the user type in where they want the hexagon to be. So let's put this code in, and I'm going to set a default color. I'm just going to set the color to green as a default value. But we're going to type in where we want the hexagon to be. So notice that notice these input values here. or these Python statements with an input. When you have input, that means you're typing something in from the keyboard. So we've been over that. So this appears on the screen. Enter the x coordinate, enter the y coordinate, enter the distance between the circles, and enter the color. Now, we have to be a little careful about the types whenever we're dealing with the input. And in the case where we have x and y, those are going to be pixel locations. And the length, that's going to be the number of pixels. And those all have to be whole integer values. So we have to make sure that we have int in front of the input whenever we're doing that. So that will convert whatever is read in to an integer. And be careful about the parentheses. We have 2 on the left, you have to have 2 on the right. So we need to make sure we convert these inputs to integer types and then assign them to our variables x, y, and length. In the case of color, color is just a word, so we don't have to change it to anything. It's already going to be a word or a string, and that's okay. We don't have to convert it. Now, once we have all those inputs, then we can call the function that will generate our hexagon. So let's put the code here for that. And once again, I'm going to make sure that the pen is up, and then we're going to go to x and y. Well, that was input here. You typed in a value for x, you typed in y, and the turtle goto statement just sends you to those coordinates. So we can pick where we want the hexagon to be. Then we will make the pen down, and then we will call our hexagon function. And this time we're going to send it the length, which was typed in, and we're going to send it the color, which was typed in. So now we can input all these values. We can call the function, and it will produce a hexagon given exactly all those inputs. So let's once again run the program, and we will now have 3 hexagons. So when we run this program, then we have the canvas pops up. So now you can see it drawing. There's the red hexagon, and there's the blue hexagon. Now, the prompts for the inputs, they're not going to show up on the canvas. They're going to show up in the shell that's over here. So let me bring this over. There's a bunch of stuff in the shell that's from error previously, but notice here in this restart, we have the enter x coordinate for x, for the hexagon. Okay, so I'm going to enter for the x value 0, then enter the y coordinate. So I'll type in 200 for the y coordinate. The distance between the circles, okay, let's make that 100. Okay, then what color do you want? Now, when you type in the color, you don't need to use quotes or anything. We can just type in the color that we want. So I'm going to type green, and I'll hit enter. And then if we look at our output, then there we have the third hexagon, and it's in color green. And notice I moved up 200 in the y direction, kept x at 0, and it's the same size. The length of these sides is the same as the red and the blue hexagons. So that's pretty neat. You can then use functions to generate turtle graphics designs. So here is the example of our hexagon. We could write functions that would produce a square and pretty much any kind of design that you want to, that you've worked out, and you can put that into a function, and then you can save that function for further use in the future. Now, let's look at a little bit more complex function. Let's do a function that will make a representation of a water molecule. Now, here's the whole thing, and I'm just going to go through it line by line, but it will generate a hydrogen with 2 hydrogens and an oxygen in a water molecule orientation. This one I had to work out a little bit, so I couldn't just write these down immediately and get it correct. So I had to do some trial and error in order to make this look right. So that's typically what you'll have to do as well. If you think of a design you want to make, you might want to draw it out on graph paper first, and then convert that drawing into the turtle commands that you need in order to generate the design. So let's go through this. I have a function, and it's called molecule. Then it's going to accept an x, a y, and a size. So the X and the Y, those are going to be the locations. Where do you want this drawn on the turtle canvas? And size, that's kind of going to be a scale. So we can make small versions of this and larger versions of this, whatever size we want. Inside the function, I am going to raise the pen so it doesn't draw. And I'm going to use the goTo function to go to the coordinates that we sent in. We sent in X and Y, so we'll move the turtle over there to begin with. Now that's going to be the location of the first hydrogen atom. And if I drew it in the conventional white form, then we couldn't see it because we've got a white background. So I'm going to make the hydrogen atom gray. I'm going to use the size to try to keep this whole thing in scale. So when I draw a dot, it's going to be 1/4 the size of the side. So if the sides of this thing are, say, 100 pixels, then this circle is going to be 25 pixels. So I'm just going to take that size, divide it by 4, and then I'm going to draw a gray dot. So it's going to be 1/4 size for the hydrogen atom. So that's what this does here. Now, the turtle is always pointing toward the positive X direction when you start up. So I want to move up and draw above the X coordinate, and I want to draw a diagonal line. So I'm going to rotate to the left 45 degrees. So that's going to point the turtle 25 degrees above the X axis, and I'm going to put the pen down. So I did not have the pen down when I drew the dot, so it's okay, it still draws the dot. But now I want to put the pen down and I want to move forward. So I'm going to do a forward, turtle forward, and it's going to go as many pixels as I pass in with the argument size. So if I wanted it to be 100, it's going to go 100 pixels. If I wanted 200, it'll go 200. And what that will do is going to draw a gray line, this number of pixels long, starting from that gray circle that I drew up here. So it's going to start from the center of the circle, and it's going to go up at a 45-degree angle, and it'll draw a gray line. Now, I want to draw in the oxygen atom next. So I'm going to set the color, the conventional color is red, so I'll change the color. And that's going to be for the oxygen atom. And since the oxygen atom is usually shown bigger than the hydrogen atoms, then I'm going to draw a dot, which is the size divided by 2. So it's going to be twice as big as the hydrogen ones, which are size divided by 4. So that's going to draw an oxygen atom twice the size of the hydrogen atom. Now I have one hydrogen on the bottom left. I've got the oxygen at the top center. Now I want to move down and draw the second hydrogen. So I'm going to rotate 90 degrees. Then I'm going to move the turtle forward. Now, this is where it gets a little bit tricky. I've got a nice solid red circle for the oxygen atom, but I don't want to draw a gray line over it. So if I started drawing at this point, if I just did a forward and I had changed the color to gray, then I'd draw a gray line over this. So that's one reason I didn't change the color yet. On the other hand, if I want to go forward all the way down to where the hydrogen atom is, I'd have a red line. I don't want that either. So what I'm going to do is, after I draw the dot, which is size over 2, then I'm going to move out to the edge of that circle. So that's what this does. It just moves forward the radius of the circle. So now it's right on the edge. Then I'm going to change the color to gray. Then I'm going to draw forward the remainder of that distance. So 3/4 times the size instead of a half. So if, for example, I have 100, then this is going to move forward 25 pixels, which is the radius of that red circle, and it's not going to draw anything. Well, it'll draw something, but it'll be red. Then I'm going to change the color to gray, and I'll move forward the other 75 pixels. So that makes it a nice, consistent color. When I get to the end of that spot, then I want to draw another gray dot, which is size divided by 4, and that'll be the second hydrogen atom. The last thing I'm going to do is I'm just going to reset the direction of the turtle so that it's pointing to the right again when I come out of this function. This will do that because I rotated up here to the left by 45, then I rotated 90, So if I rotate left again, then that puts me back where the turtle is pointing to the right. So that's a pretty long function, but it draws a water molecule. Then you can reuse this function, whenever you want to. Once you've figured it out, then you can save this code as a function. Then you just call it whenever you want to draw. Here are some examples. So let's set our pen size to a very thick 3, so we'll get a thick solid line. And we'll call the molecule function. So that's going to go to position x200, y200, and it's going to give me a size here of 100. All right. So that is okay. These two are the location, and the third is the scale, the size. How many pixels long do you want the lines between the atoms? So that's going to draw 1. Then I've got these others here, but I've got, let's just erase this call for the time being and look at the first one. So I'll just cut that out, and we'll look at the molecule we get when we call the molecule function with these numbers. So I'm going to run the program. So we'll run it, and then the canvas is going to come up, and here it is. So there we have it. So we have the water molecule drawn at position 200, 200. So x200, y200. All right. Now let's look at a different location and a different scale, and we'll draw another water molecule. Okay, so I'll put this one back in. I'll put the code back in that we just took out. So this time I'm going to go to minus 200 in the x direction, up 200 in the y direction, but I'm going to make it twice as big. So it's going to have the lines that are connecting the atoms will be 200 pixels this time. So let's run the program. We run it, and then we will see that we've got a small water molecule and a big water molecule. So now you can use this function if you need to have a drawing of a water molecule somewhere, somehow. And you can think of other things that you can do with this. Okay, well, I hope that then illustrates further what you can do with functions. And one more time, remember that if you're going to declare a function, it must be done like this. It must go at the top of the program before you ever call it. It has to be defined before you call it. And look at the syntax. Okay, you have to have the def in the name, then the arguments, and then you have to have the colon. And all of these lines follow that indentation rule. They all have to be indented exactly the same to be a part of the function. And then here in the main program, we have the calls to the function. So here, we didn't have to copy and paste the code several times. We've got a function, so now we just call it. So here we call it for the first time, and here we call it again. Okay, well, I think that gives you an idea of how you can use functions with turtle graphics. So let's terminate the video right here.